Well, hello guys, and welcome back to Mr. G Physics, the channel that can help you with the marks in physical science to improve those marks. This is Mr. G, and today we're going to work with another question for the grade 12. This time is organic chemistry. This organic chemistry is quite important because it's not difficult and it carries a lot of marks during the exams at the end of the year. This one was done in 2024 in the Northern Cape province, and it was question 5. The question said the letters A to F in the table below represent 6 organic compounds, and you have here a table with some organic compounds. The question says use the information in the table and answer the questions that follow. For compound A, write down the, and then before we read, let's identify compound A. You can see that it ends in "-ine" and therefore is an alkyne. So they say general formula of the homologous series to which it belongs. Now guys, the general formulas are always going to be asked in the exam somehow, so not other thing, but you do have to memorize the general formula of the different organic compounds. In this case it's an alkyne, and then the general formula is CnH2n minus 2. Note that most of them are like the alkanes. Alkane is the basis one, and then you have to just take hydrogens away, so many sometimes, and sometimes you have to add OH and so on. But it's almost the same. This is a structural formula of that specific compound. So let's write the structural formula of that specific compound. The first thing you have to do when you write the structural formula is to identify the number of carbon. In this case we have hept, which is 7. So we are going to have 7 carbon along a line 3, 4, 5, 6 and 7. That is the first thing you are going to do. You have 7 carbon, in this case is hept, which is 7 carbons. Then you are going to look for the functional group that we say is -ine. So the functional group of the alkyne is going to be a triple bond between carbon. That one you must also know, and that triple bond is in carbon number 3, in the third carbon. So starting from left we have like 1, 2, 3. I'm going to erase out those numbers mustn't be there, and there is the triple bond 1, 2 and 3. That is the second step here. Then I'm going to combine all the carbons, but already the functional group is there. And guys, note the following: you get 1 mark for the functional group. Then you are going to add the substituents. Now if we start from the beginning, we have an ethyl in carbon 5. In carbon 5 I have an ethyl. Okay, remember I say I'm going to remove the number, so I have 3, 4, 5. There is carbon 5, so there in carbon 5 I have an ethyl. I'm going to place that ethyl there. Let me reset that. Carbon is hydrogen there. This one is the ethyl. Remember the ethyl have the form of CH2 CH3. All right, so that is the one. Then you have 2 methyls. You have dimethyl that are in carbons 2 and carbon 6. So in carbon 2 I have a methyl. I'm going to place it on top. It doesn't really matter where do you place it. It can be either on top or can be at the bottom. And then in carbon 6, which is the one next to the ethyl, there is another methyl, which is in this case like this. I'm going to place it at the bottom. Remember it's CH3, but it could be on top. It doesn't really matter. Guys, we are done. The rest is to place the hydrogens and to make sure every carbon have 4 bonds. So we're starting with the first carbon have 1, 2, 3 and 4 bonds. There's the hydrogens. The second carbon has 1, 2, 3 and 4 with 1 hydrogen. Now the third carbon, be careful, have 1, 2, 3 and 4. And the fourth carbon have 1, 2, 3 and 4. This one have 1, 2, 3 and 4. 1, 2, 3 and 4. And the last one have 1, 2, 3 and 4. guys, this is the structural formula. It doesn't matter if you place it on top or you place it at the bottom, as long as it is in this specific way. Well, this is the structural formula, and I hope you understand. Okay, so here the marks. You will get 1 mark for writing the structural formula, of the functional group. You'll get 1 mark for all the substituting in the correct place, and you get 1 mark for the whole structure correct. But the best way of getting this word correct is by trying. Write the structural formula of all the compounds you can see at the front of you. That will help you to practice a lot. Okay, now question 5.2. Compound C is a functional isomer of compound E. So compound C and E are functional isomer. So let's go quickly here before we keep reading. Okay, they telling you they are functional isomers. Functional isomer. Now, previously we spoke about functional isomer in other videos. I hope you did watch those videos. Functional isomer, guys, we have 2 groups of functional isomers. This one is like recalling. Now, we have that functional isomer. Let's write it on this side. Functional isomers are 2 groups. They are the ketones and aldehyde and we have the esters and the carboxylic acid. That means that ketones can be functional isomer of aldehydes or vice versa, and esters can be functional isomers of carboxylic acid or vice versa. That is the meaning of that functional isomer. So now we have to keep reading. Those are the 2 combinations we have. We have to keep reading here. They say define the term functional isomer. What is functional isomer? Functional isomer are those organic compounds that have the same molecular formula but different functional group. There's 2 marks for that. And remember, they have the same molecular formula, different functional group. Those are the most important part in this definition. Now, write down the IUPAC name or compound sim. So now we're going to go here. We don't know what combination it is. We don't know what is C because we only see the molecular formula. But compound E is a ketone. You can see the functional group here. This is a ketone. You can easily see it there. Now, if this is a ketone, remember they are functional isomer. So what is the functional isomer of the ketone? It must be an aldehyde. Therefore, compound C must be an aldehyde. How do I know it's an aldehyde? Because they are functional isomer. I write it here. If E is a ketone, then C is an aldehyde because they are functional isomer. The question say that. So we have to give the name of that specific compound. And this is the compound. Okay, remember it is an aldehyde. It is an aldehyde. Now, the functional group of the aldehyde, remember, is in the last carbon that have double bond to oxygen, 1 bond to hydrogen. And this one is always the first carbon. You need to remember that one. So we have an aldehyde, we have the functional group in the first carbon and have 5 carbon. Okay? Remember that 5 is pent. And from alcohol on, you say pentan. So in this case, the best way of giving the name is pentan. Pentanal. You don't have to write the place where the functional group is because it's always in the first carbon. So that is pentanal. That is the best option of writing the name. But there is other option. You can have 1-methyl butanal, for example, because you have only the molecular formula. It means you don't know what is the structure. So you can say, for instance, 1-methyl or 2-methyl. It cannot be 1-methyl. 2-methyl. 2-methyl butanal. That is another option. That is another option. There is more option, guys. You can draw the structure and see how many you can have. Actually, all of these ones will be chain isomer. These are chain isomer now, one from the other. You can draw the structure and see what happened, how many possibilities you will get. That is a good practice. Now we are here. Question 5.3. Compound is a tertiary alcohol. Write down the name of the functional group of the compound D. It's an alcohol. So compound D, as you can see it here, they are telling you is an alcohol. Alright, so what is the functional group of the alcohol? It will be OH. And this one is called hydroxyl. That is the name of that functional group. Guys, this one is the same as this general formula. Something you have to learn because they always going to ask the name of some functional groups, and some of them have name. The alcohol has name is hydroxyl. The carboxylic esters have name is carboxyl, and some of them have names. You have to learn all of them. It is really important. Now they want the structural formula of compound. We once more have to make the structural formula, but now this one is a different one as the before we did before, because this one they're telling you is a tertiary alcohol. Okay, now that one is a tertiary alcohol. What does it mean? It means that the carbon that is bonded to the OH is bonded to another 3 carbon. So that one is going to make it a little bit different. So we have OH that is connected to a carbon. This carbon must be connected to 3 carbon. That is the difference. So in this case, we cannot have all the carbons along the line. Okay, so this one is a tertiary alcohol. Let's go to the answer of this specific question. We have 5 carbon, but we have a tertiary alcohol. So the first thing we're going to place is OH placed to a carbon, and we're going to connect that carbon to another 3 carbons. That is the first thing I'm going to do, because they are telling me it's a tertiary alcohol. So in this case, I cannot have the carbons along a line. I have 3 carbons. As I see there, it means now this is already a tertiary alcohol. However, I need still another carbon, so I'm going to place that other carbon anywhere. I'm going to place it, for instance, here. And then, guys, there is not nothing else. We're just going to complete the hydrogens. Always, once more, make sure you count the number of bonds in each carbon. I'm not going to do it this time, but you have to make sure you count. And guys, this one is going to be the tertiary alcohol they speaking about there. Okay, we can give the name just to practice. So we can, for example, if we go to the data, we know that it ends in all. We are looking for the longest continuous carbon chain. We can see it is this one here, 1, 2, 3, and 4. So it's but. But remember, because it's an alcohol, you are going to add the AN. It's butanol. Now we have to give number to the carbon starting from the end nearest to the functional group. Remember, no part of the question. Okay, so we're starting from this one is 1, 2, 3, and 4. We have a substituent. As you can see, there is a substituent here. This one is a methyl. And I start from there because there is the second carbon will be the functional group. Functional group will be in the lowest possible combination. Okay, in this case it's 2. Therefore, I'm going to add it to here. So it's going to be 2 all. And then this methyl is in carbon 2, so it's actually 2 methyl. And then I combine. So the name will be 2 methyl, 2 methyl, butan, 2 all. There we go. But that one was not part of the question. The question was just the structural formula, guys. So don't get confused with that one. But this is the name. Okay, so we go now to question 5.4. Now they say write down the letter that represent an unsaturated hydrocarbon. Now, what is a unsaturated hydrocarbon? There are one or more multiple bonds between carbon atoms. There will be one or more multiple bonds between carbon atoms. In other words, we're speaking about alkenes or alkynes. Those are the two options for unsaturated hydrocarbon. In this case, we know that compound A is an alkyne and therefore is an unsaturated hydrocarbon. So in this case, the answer is A. A is the answer for this unsaturated hydrocarbon. I'm going to write it here. That is the correct answer. Now, compound F reacts with propanoic acid in an acid catalyzed reaction. Write down there. Now, compound F, remember, compound F is an alcohol. There we go. Compound F is an alcohol, and they say it's going to react with propanoic acid. Propanoic acid is carboxylic acid. So we have the reaction between an alcohol and a carboxylic acid. Let's write down that reaction real fast here. This is the reaction we're talking about. Alcohol plus carboxylic acid. That reaction, you know, is going to give you ester plus water. That's a general name of this reaction. This reaction is the formation of an ester. Therefore, it's called esterification. Esterification is the name of this specific reaction. This one is question 5.5.1. The name of the reaction is esterification. This is a name or formula of the catalyst used. Remember, during this specific reaction, you need to add a catalyst. In this case, it's H2SO4. That is the catalyst used. It is important because it's not just a catalyst, but it's also going to be the dehydrating agent. Guys, with this question, we are done. I hope it helps. It's a very good question. From my experience, the learners struggling with chemistry, mostly with this organic chemistry at the beginning, and note the following. If you are able to do this organic chemistry, guys, you will for sure pass the exam. So it's quite important. But thank you for watching. I hope it helped. If it helped, don't forget to subscribe, to share, to write comments. I'll see you next time. Thumb up, Mr. G here.